Good afternoon, all. In the name of God Almighty and the Most High and Precious, and the behalf of Francis Engineering College, we welcome you all for this live webinar on real-time operating system. Now I request Mrs. Angeline Ranjanamani, Assistant Professor and Head, Department of Computer Applications, to give a word of prayer.
Our Heavenly Father, we thank you for this new day that you have added in our life, Father. We thank you for this webinar, Heavenly Father. As your Bible word says, not by power, not by might, but by the Spirit of God, that your Holy Spirit guide us throughout the webinar. Bless our resource person and bless the participants from various institutions and the organizers of this webinar. Oh Lord, let this webinar be beneficial for many people. We ask all these things in the most precious name of our Lord and Savior Jesus Christ. Amen.
Thank you, ma'am. Welcome the challengers. Look for the opportunities in every situation to learn and grow in wisdom. Now I request Mr. Mahadevi, Assistant Professor, Department of Computer Applications, to welcome the gathering.
Good afternoon, and all present here. First, I thank our alumni team for this program. I thank our management, staff group of institution, Professor Planning and Development, Alumni Association, friends, for their continuous support, motivation, and guidance. I welcome Dr. Krishna Kumar, Director, Alumni, and AGM of Francis Xavier Engineering College. I welcome our eminent resource person, Mr. Emmanuel Jan Jayakumar, Software Engineer, Nagra Vision India Private Limited, Bangalore, for his presence. I extend my hearty welcome to the participants from various colleges, industries, and from our college. Once again, I welcome you all for this webinar, Real-Time Operating System, organized by the Department of Computer Application, Francis Xavier Engineering College.
Thank you, ma'am. Small cheer and great welcome makes a merry feast. Now I request Mr. Krishna Kumar, Director, Alumni, and Assistant General Manager, to share a few words about this live webinar.
A very good afternoon to everyone. I'm happy to participate in this webinar. First of all, I welcome Mr. Emmanuel John Javakumar for accepting our invitation for giving this webinar. And my best wishes to all the participants, HOD, and faculty members, and all the students. Thank you all.
Thank you, sir. To be inspired is great, but to be an inspiration is an honor. Now I request Mr. D. Stanley, Assistant Professor, Department of Computer Applications, to introduce the resource person.
Good evening to everybody. I feel much pleasure to introduce our eminent resource person, Mr. J. Emmanuel, who is none other than our alumni. He is always well known for his discipline, commitment, and hard working. He completed his undergraduation in the discipline of computer science from St. Xavier's Arts and Science College, Palayangote. He completed MCA from our institution in the year 2014. His core competencies are C language, scripting languages like shell script, real-time operating systems like Linux, ECOS, embedded toolsets, then the target interfaces like connectors, microcontrollers, and the delivery systems. He is having a real-time experience of working as a software engineer in SureSoft System Private Limited, Pondicherry. At present, he is working as a software engineer with the Nagra Vision India Private Limited, Bangalore. His strong professional experience comprises of having strong experience in the field of embedded systems, having proficient knowledge in C, real-time operating system, and DVB standards. He is a technical expertise of understanding graphical user interface, designing and development, then the middleware integration, and programming and debugging. He designed and implemented the satellite tuning process and user interface screens. He designed and implemented the multi-operator feature for an Italian market. He implemented the factory process flow in the middleware for Android-based application. He played a major role in the user interface screen design and implementation of various Forex products. Also, he received the Best Employee Award for the fourth quarter of 2016 for implementing the user interface screen in short span of time. So totally, he is having nearly 4 years of experience in the field of embedded system. So we feel much proud in introducing such a renowned personality in front of you. We assure you that this webinar will be an innovative one for all the members who are attending. Thank you all.
Thank you, sir. Now the session starts. And over to the resource person, Mr. J. Emmanuel John J. Kumar.
Welcome, Emmanuel. You can start the session.
Good evening to all, and let me introduce myself first. I'm Mal John Jackmar, and I am proud to say that I am an alumni of Francis Xavier Engineering College, and currently I'm working as a software engineer in Nagar Kudalski Group. It is in Bangalore, and today they provided me an opportunity to take a class on yes ma'am.
Your PPT is not visible.
Just a second. Yes.
Yes.
Okay. Okay, I think let's get into the topic. And today we are going to discuss about what is real-time operating system. And I think most of the guys was not aware of these things because real-time operating system was mostly used in embedded related fields only. But we can see it in a real time also. The name itself it tells about it's a real-time operating system. It is applicable for the real-time products. The product means whatever we can say it as whatever it may be. It may be a washing machine, or it may be a set of boxes, or it may be a traffic signal monitor, or whatever it may be. And most of this these products will be mostly deals with a single purpose. Let me share you something, because if you go with the traffic monitor signal, its purpose is to deals with the traffic monitoring purpose only. uh, Let me compare with the general OS. General OS generally deals with the multiple applications at the same time. Yeah, now we are looking to what is RTOS. RTOS is just a real-time operating system. Mostly it was applicable for the real-time system products. Okay, mostly we can see for example, we can say microwave oven and traffic signal monitors and washing machines and mostly set-top boxes. And yeah, mostly it was compared to general OS. It was good because it was more accurate than the general OS. But general OS can deals with multiple application at the same time. But RTOS is defined for a purpose which deals with a single process at a single time. Okay. um, then let's see what is the difference between general process OS and RTOS. Yeah, generally we all very well know about the general operating system, because mostly we are used most of the guys having the laptops, computers and all, we are having the general process operating system, and which deals with the multiple application. For application, yeah, at the same time we can work with the notepad, wattpad, or whatever the application you want to work with, that you can do it the same time. But in real-time operating system we can't do that, because it is defined for a single application only. It deals with the single application. Okay. Yeah, these are some of the examples which are having the real-time operating system. Yeah, we can see, yeah, microwave oven, fax machines, washing machines, set-top box, traffic signals, and etc. And okay, and let me go with the task. Okay, and what is task? Okay, let me go deep in this. A task is generally an application. We can say it as an application or a program. Generally we can take an example of a notepad. Let us assume a task is a notepad. Okay, if we go for a notepad, whatever we are having, generally we used to work with notepad for typing some of the text and all. We are trying to saving it, and we can share it, whatever we can do it with that. But uh, whenever you look into the notepad, you can see a cursor blink on the start position. So have you ever think what is happening behind that cursor blink? Yeah, there's a background process running behind that cursor blink. It should be a thread. Okay, what is the process of thread? uh, it looks it's like a simple program, or we can say it as functions. And the function, it deals independent process to act a part of the task. Yeah, notepad is a task. In Notepad, we are having multiple threads. Namely, for cursor blink, we are having a thread which deals with cursor blink, and keep on monitoring where the user lastly texted somewhere, and it shows blinking. uh, it shows some status to us, because we used to know what it will do. If we type something, it will keep on going on that things. Yeah. And one more thing, whenever user try to type something in that notepad, we can see, yeah, like there is something behind that. uh, how it was entering, if user entering a text, how it get into the background. So there is a thread began running in that application. It deals with how to monitor the user status. It's more or like it deals with, yeah, whenever can user enter the text. Yeah. So the thread deals with, whenever the user enters something, it takes or fetch some inputs from the users, and it deals with the input begin the background. Okay. And guys, am I audible?
Yes,
Ah,
yes, yes,
yes,
Iman.
Yeah. Okay. And if you have
Yes,
any
sir. Yes.
yeah, yes, if you have any doubt in this thread and task, you can raise it immediately. And now we are going to look about some of the features in RTAS. First one is preemptive kernel. What is preemptive kernel? The main difference between the general operating system and the RTAS, the real-time operating system, is based on preemptive kernel. Because yeah, we can look in general operating system, if it deals with multiple application at the same time, maybe some of the media player, and we are opening a media player, we are opening a notepad, some of the application we are trying to work with on. Okay. So as per CPU, it can deals with the single process at the, at the simultaneously it can sync up with multiple process, but at the same time, at the single point time, it deals with the only one application. That's the point I'm trying to say. So what is the difference between sorry, hello, am I audible, ma'am?
yes,
Sir, I
Yes,
think,
yes, you are audible.
yes,
okay, okay, sorry, I
Close
think,
the presentation.
okay. Okay, suppose if a user deals with multiple application at the same time, there is some priority, which means if user watching a media player, it is the high priority, because we no one want to disturb the audio video things. But if you work a notepad in the background, it's a less priority compared to the media player. So mostly general OS not deals with this, but we can't assure, it's look like deals with the priority based priority based things, but we can't assure, because general OS not supposed to uh, do by priority based, but RTOS deals with. That's the only difference. The RTOS deals with the process. That's okay. Okay, and the second thing, yeah, here we can see with the slide. Yeah. So the second objects of that RTOS is semaphore, and mostly semaphore is like an variable which is used to synchronize that thread. Okay, morely we can say, just I'm saying an example. If we're going to an ATM center, okay, uh, just like so suppose we can assure a task, okay, whatever may be task, it depends on some of the threads. So the thread is synchronizing something and it deals with the task. Okay, so now I'm trying to explain. Generally there are two thread available. Okay, namely we can assume that two persons are waiting for an waiting in an ATM center. They are trying to get some amount on the ATM machine. Here the ATM machine is the common resource. Okay, but uh, the thread one is the person one and thread two is the person two. Okay, they are trying to get some amount. So here uh, If one was accessing the ATM machine, no one should disturb him, because it's a common resource. So we have to schedule something on that to get to deals with the process in a synchronous manner. So we used a semaphore. What it will say? Semaphore, it's like a signaling mechanism. Okay, just assume the ATM machine is a common resources. We are trying to access it. But the second thing is thread. Thread is the number of persons available outside in the ATM center. The ATM machine is covered by a ATM center, just like a room. Uh, it is a semaphore. We are having a door. Yeah, just we are having a door of that ATM center. It deals with them. And normally, what can we do with this? We can lock it and we can release whenever we get some amount from the ATM machine. We just get exit of that room. That's what I'm trying to say. Yeah. Now person one is trying to enter into that um, ATM machine. So in some for we have, but before that we have to understand one thing. In some for we are having two things. One is binary sum 4 and second one is counting sum 4. Binary sum 4, which deals with zeros and ones, so which means it has only one way. Okay, it's a ATM center which having only one door and only one ATM machines. So if I want, there are two persons available waiting outside to access the ATM machine, but we are having only one door which is the semaphore. Okay, so if one person get inside of the want to access the ATM machine, he should enter into the door. What I'm trying to say is, when he enters into the door, he just lock the door. What does it means? I am trying to access the ATM machine. No one should disturb me. Okay, that's the deals with sum 4. Once the person gets some amount from the ATM machine, his process over. Okay, then he tried to get exit from that ATM machine, then he releases the door. That is the mechanism we are using. Then the next person can access the ATM machine. So the synchronization way is properly happened with this semaphore. Or else, if assume that if there is a no door in the ATM machine, what will happen? uh, but usually we are humans, we try to access one by one, but in operating system it is not possible. They are trying to access the same common resource at the same time, so it will leads to some crash and some misbehavior with that with our application and all. So some 4 deals with a good way to synchronize the thread to make a proper process for our application. Okay. Okay, and second thing, we are having some of the scheduling algorithms. Yeah, without scheduling algorithms, CPU cannot perform anything on that. Uh, Let us assume, okay, if we are working with the general operating system, we are having number of applications in that. So normally what we are trying to CPU is only one CPU we are having. We are trying to access the CPU, but we are having multiple application. So what we have to do? There must be algorithm or the scheduling things that operating system should deals with it, or else we can't access the common resource, which means the CPU we can't get it in a synchronous manner. So we have to do it in a proper way. So there is a first method is first in first out. Okay, which means assume that there is an active queue which are going to access the common resource in a proper manner. So number of application in an active queue, whatever the may be the order, the first come first serve will be proper in a proper way. Okay, if an application will be placed in the first in the row, then it gets the first services. If it in the second place, it will get the second service. By the same way, it deals with the all the process. The process means I am saying about the applications, so it deals like that only. Yeah, and the second method is shortest job first. What is means shortest job? And each and every application have a some of the execution time, whatever it may means. If you enter something in a notepad, it is a small part of an application, and its application execution time is very less. And if we compare to a media player, it's keep on going, so we need more time on that. So that's why in this manner, if we go with shortest job first algorithm, it deals with them. smallest process first. Yes, sorry, there is some noise now. Okay, okay, let me continue. Okay, whenever the CPU deals with the shortest job, whatever it may be a notepad, its execution is time. Oh, okay, then it will come into the first row. If it was a media player, it was a long-term process, so it deals with them the last thing. Okay, so we have to keep it in the last row, and we have to deal with in the last way. Okay, that's why mostly we are not using this sort of the first algorithm. And, nowadays, I think there is no one is using this one, but there's algorithm. It was defined by operating system. So I'm just explaining them. And one more thing is a round robin, and this is a good algorithm. But while commenting is while sharing a common resource, I think it's not suitable because round robin. Uh, Let us assume if you are having a four application in a manner, okay, in a round robin manner, it will give same execution time for all the process. Then what will happen if no one should complete in a proper way, which means in a quick time. If a notepad is an application waiting in the queue for a long time, it whenever it gets the resources, for example, if it needs 4 milliseconds to execute the process, it will get only 2 milliseconds in the first round. Okay, whenever it goes for the second round, then only it get the next 2 milliseconds. Oh, so it leads some, we can't see it, but it leads some more execution time in that process. So this is the drawback of the round robin, but generally it was nowadays it was using in many of the application. Yeah, it's a good one. And next one is the priority based. Okay, yeah, in real time operating system, mostly the priority based algorithm deals with, yeah, because let us assume if there was a, with the real-time example, if there was a temple outside, and there will be two queues. There was a common queue once, and there will be another one queue. It will be a VIP queue, okay, which deals with the prior person will enter into the temple. uh, he or she should not wait in that in a common queue. So he or she wants some, because they are VIPs though, so they want to enter the temple in a very fast way. So by the same way, the operating system deals with the same thing. If some of the application has less priority, and some of them have high priority, and some of them have medium priority. So whenever the CPU needs any application, it deals with the higher priority task at the first. Okay, up to the higher priority task deals the execution time is deals with more than the low priority task never gets time to execute, because it was keep on working with the higher priority task, so it won't work. So this is the big drawback of this priority based algorithm. And next, yeah, am I audible or?
Yes, Iman, you are audible.
Yeah.
Participants, kindly select Iman John presentation and pin it. So others' presentation is not visible for you. And those who are presenting, kindly avoid presenting yourself. Thank you.
Okay, and the next topic is message queue. Message queues mostly used to make a communication between threads. Uh, Before I said there is a notepad which is having multiple threads work with it to make a task in a proper manner. So let us assume there is a cursor blink in that notepad, and user inputs in, yeah, one more thread is monitoring the user input, and one more thread is working with the cursor blink. So these through thread has to make a communication to make the execution process in a success way. So they are trying to make a communication. How did they do? We can do it by a message queue. It's more or like it's more or like an array. in C language we can say it as an array. They are keeping an array which number of messages we can create, and generally if you google it we can take some of those general syntaxes of message queue. They will keeping an array which having the maximum size of the queue, and each message they are keeping a separate size for that. So with that we can send messages and receive messages. This will deals a big communication between two threads. Then it can easily synchronize. This is also used to synchronize between the two threads to make the process success. Moreover, it deals with the communication only. So if thread 1 needs a input from the thread 2, or else thread 2 needs input from thread 1, it uses message queue. Then only it can easily access the process in a good way. Okay, and we are having watchdog reset. It's a functionalities of our task. Let us assume, yeah, we may face some of the hang issue in our operating system, and then it will be recover automatically in some more time. Because what does it deals with? Maybe it deals with whenever user trying to open multiple application, or whatever it can say, whenever you used to try to open with multiple application, or there will be some code mistake inside that application, there is some drawbacks of that application deals to get hang in that operate our application. So overall the system get hang, because if it is was a higher priority task running in with the cpu, it won't allow other tasks to execute. So then what will happen? The higher priority takes the cpu, then there is no way to get escape. Then the no way to that cpu get escape from that task. So what it will happen, it get hang. Whatever you can say, it's more or like a deadlock. Okay, and this is the functional, it's a kernel function. Moreover, it deals with kernel only. Whatever kernel will do, it will keep on monitoring the task whatever performing with the cpu. If the cpu was idle for a very long time, it deals to restart the system automatically. Because it's a higher priority thread, because no one should get hang with the cpu for a long time. It won't, the kernel won't allow us. So this is the good function the kernel is using to restart our system whenever it gets hanged for a long time. And and I think moreover, yeah, we can some more thing to deals with the artist. Yeah, artist, I think mostly we can use it with the sdbs, because I'm having more knowledge with the sdbs. In artist, it's a real-time operating system we are using with the set-top boxes. uh, in sdbs we are having several inbuilt threads, because we have to fetch some channels from the stream, and we have to do tuning process. We have to get input from the users and whatever it may be. Yeah, user can input at any point of time. So we need to keep a separate thread to monitor the user inputs. And one more thing, yeah, we have to present the user interface screen for user to interact, for user interaction. And mostly it deals with tuning process. Yeah, tuning is a very big process. The one of the mostly high priority thread deals with the tuning process, because without channels we can't do anything with the set-top boxes. So it's mostly deals with tuning. So we are using real-time operating system in there, because we have to do with priority based algorithm, because tuning is the highest priority thing. We have to do it always in the background. Then only user can watch the channels and do some interaction with the menus which are available in that set-top boxes. And we can switch channels whatever it may be. It deals with the RTOS. Okay, and generally, yeah, I think I want to share some more points with task. Yeah, is task is more or like a program or an application, we can say it. uh, Yeah, for example, we can take, let us take one more example with the VLC media player. It's just a task. What all it deals with? It has a graphical user interface. It's more or like an Windows. Okay, it's there is a separate thread inside of the task used to fetch the input from the user, whatever it may be. Anytime user can press the button in that we'll see media player, play, pause, or something, whatever it may be, or else he want to switch to uh, next song or whatever it may be. He wants some user interaction with that application. So there is a separate thread running behind in that task to get some to fetch or get some input from the users. And suddenly if you are playing a song, it's keep on playing. Suddenly if you are pressing a pause button, what we have to do in the background, we have to stop the audio content, we have to stop the video. So we are having separate several process running begin with that VLC media player. Let us assume for audio we are having a separate thread. It's keep on running to fetch the audio content from the source file to make it to display for the user. And for the by the same way, for video content also a separate thread doing the same thing. And for moreover we can see some subtitles and all, we are having some closed caption and all having. For each and everything there are separate thread running behind the task to make it a complete task. Without thread there is no task. Thread mostly deals within the task to make it in a success way. So whatever it may be, thread, yeah, if we make a good success application, we need some more thread behind the task. So then only we can bring up a good communication between that thread. And yeah, without communication we can't do anything. Yeah, if we press the pause button, what will happen? We have to stop the content now. Then what we have to do, we have to send the proper message to the video thread, then it will stop the video. Then we have to send a proper message to audio thread, then it will stop it process. Okay, unless it won't do anything. There is everything in the task, it's began with the big process which are morely inclusion of several threads running behind the task. That's what my point. And morely there's a big communication going behind within the thread, then only it can easily communicate with everything. I think you can get something from thread. Is there any doubt and all in that thread or task? I think if you raise any doubts, then I can explain it more. Is anyone having any doubt?
So far, no questions, Emmanuel. You can proceed.
Okay, thanks, ma'am. Yeah. Okay, mostly, yeah, I'm saying about the example with VLC media player. So what it will deals with? So it having, I said it having two threads. One is for audio and one is for video, and there must be a sync up with that audio and video. How it is happening? Because audio is a separate thread and video is in a separate thread. How it was taking accessing the CPU at the same time? It is. And one more point, the CPU can't access multiple thread in the same time. It will give the CPU a thread for once only. For only one time, a resource can access the CPU. Multiple tasks can access the CPU simultaneously because it is not possible in anywhere unless it is a multiprocessor CPU. Okay, multiprocessor CPU deals with something it can run more process as per the CPU configuration. Okay, but in RTAS it is a single processor communication, so it deals with this proper synchronization way. So it deals with some of the scheduling algorithm. So yeah, previously I said about the scheduling algorithm, and it's mostly based on the deals with priority based. Okay, if audio or video let us compare with that. Video is a high priority thread compared to audio, because video has more it leads more memory to fetch the content from the source and leads to display. So it needs more memory, more time, and more execution time, and whatever it needs more things compared to the audio. And audio is the next priority thing when compared to other tasks, because user interaction, it's a kind of simple execution. It won't take more time, but anyway it's need a thread to run the process begin the task. Okay, there are several kinds of threads running begin this. So how can it communicate? And we need to uh, access the CPU in a proper manner. Yeah, there is a source file we are having, whatever maybe, let us say a song in your C drive, or whatever drive you are keeping a song in your source. If I try to play that songs, I need to fetch the source content from the source file, and I keep on going with that. So rendering that source file and keep on going with that display. I have to fetch the content from the source file, and I give the some of the input to that VLC media player application to bring it into the display. So what I have to do? Yeah, yeah, we are having some more number of threads, so there is only one common resource file. For audio content we need to fetch from there, for video content we need to fetch from there, and mostly what else, if there is a subtitle we have to fetch from there. Yeah, more number of threads deals with that source file. So what do we have to do? We need a proper synchronization method, then only we can properly fetch that source file and we can bring back to our display. Or else what will happen, it maybe leads to some corruption, or whatever maybe some misbehavior with that source file. If it leads to some misbehavior with source file, we can't play it anymore. So we don't want to deal that things, so we need a proper synchronization way. So for mostly for that synchronization way we are using a semaphore. Yeah, mostly I said there is a two types of semaphore. One is binary and one is counting semaphore. Yeah, I haven't say about counting semaphore, I will say in for, but here we will go with binary semaphore, because if an audio thread trying to fetch some audio content from that source file, no one should disturb him. So it's make a sum for wait, and it's fetch some content, audio content from that source file and bring back to the display, and it's release the signal. So next available thread is video content. So the video thread will take fetch some content from that source file, and whenever it execution get over, it release the thread, it releases the sum4. So the next thread can access that source file with that sum4. So it will make a proper way and it won't disturb the source file, but we can fetch the input from source file, but we won't never disturb the source file. So it's a good deal. Sum4 which leads to that. Let us assume counting sum4, which is mean we are having number of semaphores. We can configure the how many number of semaphores we want with kernel. There is some of the APIs we are having. We can Google it and search for it. uh, let us go back with that ATM example. Yeah, before that, for binary example we are having only one ATM machine and we are having only one opening center, which means the door we are having only one. But let us assume we are having multiple resource inside, more number of ATMs inside, and we are having more number of doors. So it's a counting sum for, let us assume there may be 4 doors and we are having 4 ATM machine in that center. So what can we do? At the same time we can access the resources. A 4 person can access the resource at the same time. If the person number 5 wants to access the resource, he should wait outside until any one of that resources get released. This deals with counting sum for. With that counting sum for we can do a lot, but it will create more problem in synchronization method. Mostly kernel deals with things. Kernel is a big part in operating system, and yeah, mostly some for it deals with mostly it's deals with the synchronization path, process between the threads. Okay. Uh, any doubts in this session? If you have any doubts, please raise it. I will share you something.
Participants has given two queries, Emmanuel.
Yeah.
One is which algorithm, Kalpana Tripathi, she has asked one, which algorithm is used in today's smart devices? That is one.
Uh, yeah. Mostly in today's devices, mostly it deals with general voices only, because RTAS it deals with in a single process. So it's very less cost when
The
compared to
screen
general
is not
voice.
visible.
When
Presentation
compared,
is not visible.
just a second. Yeah, and in nowadays most of the devices it deals with general voices only, because RTAS which deals in a single process only, so we can't go it, with multiple devices. Uh, Normally today there are more number of smart devices. For example, we are having phone and all which deals with multiple application, but with RTAS we can't do that. But as before I said, for traffic signal monitor and all, it's a single process, so we can go with that. For microwave and washing machine and all, and nowadays they are using in TV also. Some of the TV also we are using auto system. Mostly we are using general OSs only.
Okay. And the second question is, uh, what is synchronization and how it may be in threads? I think
What is, yeah, okay, let me share. Yeah, synchronization which deals with okay, there is a common resource. Yeah, I'm saying a common resource. There are two threads waiting to access the common resource. There is a, yeah, there are two threads waiting to access the common resources, and we are having only one CPU. I think there is some voice. Okay. Yeah, I'm saying that ATM example is a very good example. I think I can explain it one more time, because ATM machine is a common resource. We are having only one, and and the next thing, we are placing it in a ATM center, which means a room which is having a door to access the ATM machine. And um, if you want to access the ATM machine, we have to enter with that door only. So whatever may be the persons outside the ATM machines, which means the ATM center, they have to wait for several times to access the common resource, because we are having only one resource, and we are having, which means in operating system we mentioning the resource is a CPU. Okay, at the time, at the single time, and the CPU can process in a only one task. Multitasking is not possible in a single CPU. If we go with multiprocessor, we can do it, but in a single processor we can do it only one process at the time. So by the way, so synchronization means, okay, let us assume there was a CPU. There are two more threads who want to access the CPU at the same time. If there was a no synchronization process or no scheduling process, what will happen? It will try to corrupt the it will try to corrupt the common resources. Let me give another example. Let us assume there is a global variable in C language. Okay, we will go with C language. There is a global variable, and there is a two thread accessing the global variable. One is to read and one is to write. Okay, the read thread will get the read the global variable and deal something with that, and the write thread will try to write something on that. Yeah, it's want to change some value. Let us assume our program process is to print uh, print even number in a sequence manner. Okay, let us assume two from starting from 2468, like that we have to print. Then what can we do? uh, Yeah, thread 1 will read the value and thread 2 will write the value. Let us assume thread 2, what it will do, it will increment a value, and yeah, just if we increment a value, the global variable still remains the same whatever the values lastly updated. So the thread 2 will keep on increment the value by 1. So it will have, what it will happen, it will keep on starts from 1 to up to, it will go on, keep on going. And for the thread 1, what it has to read the value, and it has to um, whenever it want to read, whenever the values become an even value, then only it needs to read. So what can we do? So we can make a yeah, here we can make a sum for while writing the writing means updating the global variable, we should not disturb the thread. So without sum for we can't do it, because we have to make a synchronization process, or else we can't do anything with that global variable. uh, if we want to try something with that global variable, it will really corrupted, because if I want to read the value whenever it was a even value, but if I allow the thread to update the value keep on going, then what it will happen, it will keep on increasing the value, then the thread 1 never gets to execute. So we need a synchronization process there. So we need some for to sync between two threads, and then only we can access the common resource in a proper way. I think yeah, it's okay, or do you need any clarification more than this?
I, yes, I think they are satisfied.
Okay. Okay, I think they're all mostly about operating system. Yeah, it's still, it is whenever compared to generic OS, it is more accurate. Compared to general OS, the RTOS was more accurate and less cost, and the execution time was very less, because it is a single process. No, then we can execute is more faster compared to general OS, because general OS generally deals with multiple application at the same time. But RTOS really deals with the single application with the single processor. So the execution time was really very speed in an efficient manner.
Another question is there: how to develop RTOS? RTOS.
It's uh, RTOS is generally a OS. We can download it, but I don't know how to develop it. Sorry, it's more or like an operating system. I think I don't know how to develop it. Yes, any other questions? Any other
What,
questions, ma'am?
what is the fastest OS as of now? As per now.
Fastest OS. Mostly it deals with the Linux only. Linux operating system is more secure and fastest operating system. Yeah, the security system, while comparing to general OS or whatever maybe the Windows having, it is nowadays Windows are trying to get some information from a Linux operating system. They are trying to adapt them Linux operating system within the Windows operating system. So in such manner, the Linux operating system was very good, and it is most faster, and it's more secure than any other operating system. Yeah, any other thing?
Semaphore concept is helpful in research.
Sorry, ma'am.
How? In what way semaphore concept is helpful in research?
Uh, in research, uh, in research means what kind of research, may I know it?
I think while doing doctorate degree, I think they are asking that.
Uh,
The threads in semaphore.
threads, it's a inbuilt processor. We can't do. Yeah, we can understand what is running behind the process. That's the thing we can do, but other than that, uh, I think I don't over up that. Sorry, ma'am.
So in Linux, which version is faster is the question. Another question.
Oh, they are asking what OS is the faster one while
Which
comparing
version
to one.
in Linux? Which
In
version?
Linux, which version they are asking?
Uh, Version, I know Linux is faster, but I just have to Google it and I have to share it. Sorry.
Okay. Out of the four algorithms, FIFO, SJF, round robin, and watchdog, which algorithm is best suitable? They have asked.
Which algorithm for real-time operating system? The priority one is very good. For general purpose, it will goes with round robin and all and shortest job.
For today's devices, which algorithm is best?
For today's, I think it's better to go with the round robin. Yeah, and that is the better way because each and every thread can get some execution process with that CPU. So it is better.
Round robin.
Yeah.
And next is
Ma'am,
Sorry.
Varshini, I think you mute yourself.
Hello. Yeah.
yeah, maximum number of OS that can be installed in a single PC.
Maximum number that's based on our configuration only because I think we can do it more number of operating system we can keep it in our system, but it will uh, it will slow down our system because based on our memory depends on our processor and all. It deals with that only.
Okay, okay. Which scheduling is best for real-time operating system?
It's
Only
mostly priority based algorithm is good one.
Participants, any other queries you can post in the chat box. They've asked, can you explain semaphore once again?
Okay. Okay, I will do. Okay, just hold on a second. uh, okay, let us shall I say with the same example, or I will go for a different one?
I think you can explain the different one for semaphore.
Okay. uh, just hold on a second. I also okay, let me go with the example. Okay. Yeah, very simple example. uh, Let us assume with the house owner. Okay, he wants to build a house. Okay, what he will do, after basement, what he will do, there are laborers, some of the laborers working with to be building the houses and all. For each and every person, they are having a, separate uh, separate work on that. Someone used to bring the bricks to the mason, and the mason will start uh, building up with the bricks, and someone has to mix up the sand with the cement. There are separate thread working. Let us assume there are three threads. Okay, one is the mason. He used to build them a building with that bricks. The first person. Let us assume the second person. uh, he's a labor number one. He used to mix the cement with the sand, is number two. And let us assume the third person, he used to bring that cement and bricks from somewhere to the mason. Okay, there are three person working to construct a building. Okay, when will the mason and the the person who is carrying bricks and all will get the work? Whenever the uh, yeah, whenever a person who is working with mixing the sand and cement, whenever he mixed something, then only the second person is getting some resources to get there and bring back to the mason. And the mason will get some work when the intermediator, which means the second person brings some brought some bricks or some mixed cement or sand to him, then only he gets some work with that. So they are in a sequential manner, so they have to synchronize with something. So let us assume uh, there are three threads working. Our our goal is to construct a building, but for that we are having three threads. One is working as a mason. It's constructing build with bricks and sand, and the second one is to carry some bricks and all, and the third is mixing up the sand and cement. So there should be a common resource and all. So what will do? So everyone has to come to the work at 9 a.m. They will start working, but they want some resources. So what will be the resource? The sand and the cement is the resources. So what they have to do? The first person, whenever the first person complete that the work, then only the second person get into the job. Whenever the second person completed that his job, then the third person, which means the mason, get into work, or else no one can get into the work unless the first person can complete his work. uh, Here we need some for, because without sand and bricks, and mason can't build anything. Without the same sand and bricks, the second person also can't work. So here the high priority is for the first person who is mixing the sand and yeah, sand and the cement. So he is the first person accessing the resource. The sand and cement is the resource. Okay, so he's trying to mixing up. Until that, the thread number 2 and 3, which means the mason and the intermediate person, has to wait for more number of time. Okay, until the first person did his job. So whenever the first person did his job, uh, whenever he get into the work, he make a sum for, let us assume there is a sum for, there is a only one sum for both of them, three of them are using. So whenever the first person get into the task, he used to put a weight and he works with mixing up the sand and cement, then he release the log. Until that, the second person can't get into the work, because there is only one sum for, then no one can enter into that, no one can access the common resources, which means the cement and sand. Okay, whenever the first person releases the sum for, the second person will get into active. Then he will put a weight, and he will try to carry the cement and sand to the mason, and whenever he reaches the mason, he will release the sum for. Then the third person, which means the mason, can get into work. Whenever he trying to work, he will put a lock, which means the sum for weight, and he will get into work, and whenever he complete, he will release the task. This is a synchronization process which all are working to make a process in a success manner. Okay, I think you get it something from this.
Another query
Okay.
is what purpose we can use Linux?
For more safety, we need Linux operating system only, because hacking is mostly not possible in Linux operating system while comparing to general OS.
Okay. Another query is in colleges, which OS is preferable for student assignments?
Its general OS is very suitable for students.
Uh, Another from JC Len, how to check algorithms in the system OS?
Uh, it's a typical question. We can go with the task manager. We can check from there. some of the windows allows us to see the what is the scheduling algorithm we are using for our system. And mostly nowadays in recent OS they are not allowing us to see the scheduling algorithm or what we are using in our system. And I think we can see it in a older version, we can see it.
You can check in the properties.
In task manager we can there are several tabs with the performance and all, we can go with that and search.
And another question, what is the front end and back end for Windows operating system?
Windows operating system front end mostly is depend on the user interaction screen, whatever it may be. Windows, for each and every application there is some user guide and all, which means user interface screen. For VLC media player we can see some of the screen which containing some number of buttons and all. By the same way we can in notepad we can see a screen which having some more number of white spaces. It's a blank screen with a white blank white screen, we can enter something in there. The front end will be the user interaction screen in for each and every application. In mostly in all OS it will deals with that only. Mostly backend which deals with the storing process, whatever we want to. Yeah, if we want to store something we have to go with the backend. If we want to fetch some data and all, we have to get it from backend. And if you trying to save something, it will go into the backend, which mostly deals with the secondary storage or primary storage device. It deals with backend.
Will the kernel be the backend?
Kernel is a part of operating system, it's not a backend. It deals with uh, the task and threads, it's not a backend.
Okay. Second is how to learn Linux for beginners.
We can google it. There are more number of tutorials for beginners, we can simply refer it from Google.
Another is so is there any link for beginners to learn Linux?
Okay, I think I can share you. Yeah, I will share you after this session.
Another question is based in industry perspective, which OS is suitable for students to learn?
uh, it's moreover we are using general operating system, and real operating system deals with a single process now, so it deals with very limited amount of products. So mostly computer we are having Linux operating system, general OS. It not deals with the real time operating system, it moreover deals with the simple products and all. So it's that we can deal with the general OS only.
Okay. Explain inter-process communication, sir.
Interprocessor, it's just like an application call. Yeah, if you want the communication between application, let us assume there is two application. We are having a VLC media player and we are having a just like an MX player. We want to communicate something between that application, then we need a IPC call. It's moreover like in code level we can say it as a there is for each and every application there will be an application ID. So if you want a communication between that application, we must know about that application ID and all. If I want some data from that MX player to that VLC media player, for the VLC media player they are having a separate application ID, for MX player they are having a separate application ID. if we if we want the communication between two application, we must know the application ID, then only we can bring a proper communication between that application. The IPC call mostly deals with that uh, application. Yeah, mostly deals with that application ID, and there are several processes to follow to make a proper IPC calls.
Okay, next is presently using Windows 7 is protected or not?
It's a good one. It's a highly protected one.
Okay. Difference between 32-bit and 64-bit operating system.
Yeah, it's moreover deals with the fetching the instruction. uh, if a 32-bit operating system, it deals with fetching a, if it's tried to fetch a input or anything as an instruction, it will go for 32 bits. Okay, for example, if any instruction pass over the CPU, it will goes by 32-bit. In 64-bit, it deals with 64 bits. Whatever may be the instruction. For let me show you. Yeah, for Notepad, you are entering something. The CPU want to fetch some value from that Notepad application. It deals with for 32-bit OS. It deals with 32 bits. It's more or like WAD. It's a 32-bit WAD, and for 64-bit OS, it deals with 64-bit WAD. We can say mostly the WAD is depends on like that only. Mostly we can see it in C language also. If it deals, yeah, in dev cpp it's a 32-bit compiler. And for normal bc compiler, it's a 16-bit compiler. We can see the difference word padding. If we allocate some memory or we can register some of the variables in that, we can easily identify the difference how the cpu is fetching the input. For simply, if we try to declare some variables int a and b, the 32-bit compiler will fetch the value as 4 bytes, which deals 8 bytes overall. But 64-bit compiler, it takes an 8-bit for each and every data type. So mostly it deals with like that only.
Uh, okay. And then next is how to identify an application ID.
uh, yeah, it's more depends on code level. There are some of the kernel APIs and all. After this session, I can share you the APIs details, because there are some default kernel APIs which is used to help us to fetch the application ID and all. So that only we can get, or else it's a dynamic configuration. So we can't assure this will be the application ID and that will be the application. We can't assure it because it's not a hard code down. It's a dynamic one. Whenever the application get into action, they will get an application ID.
Okay. Next is how can you differentiate general OS with real time OS?
Yeah, mostly it's the general OS deals with multiple applications at the same time. Because in general OS, we can say, yeah, in processor configuration we can say we are having i3 processor, we are having i4 processor, i5. That's what we are saying now. i3 processor which can deals, which means it can run three processes in simultaneously, because it has three processor. Each and every processor has able to run a single processor at the same time. But in real time operating system, it has only one processor, so it deals with only one application at the same time. So mostly in real time operating system, it deals with the product which are having a single application. Then only we can get it, and then only we can access it very faster and very safer. Yeah, anything else?
And can you tell about Python?
Python, just it's like a sorry, I don't know of that very much. It's more or like a scripting language. It used to, I think, in setup box field we used to that for build automation. We do build automation. We used scripting language. In that way, we are just using the some of the Python script and all. But I don't much knowledge on that.
Which OS is being used in your industry?
It depends on the products. Because if we want a very secure and single application process, we will go for RTOS, or else mostly we will deals with the Linux operating system only.
And the last is there any website for learning OS?
Yeah, there are more number of websites available in internet. Yeah, I will share you some of the mostly used links.
Okay. And the last is any OS have inbuilt security system for banking transactions?
Oh, banking transaction is morely depends on the application. It's not deals with the OS, because any OS, yeah, application deals, yeah, it's not depends on OS, because it's banking system. For example, if we go with HDFC Bank, they are having a separate banking application, so it's not dependent on OS. Yeah, but they will go with some OS that the banking application run with this OS. About this OS configuration, we can run our application that we can deal. But for OS and that banking application, there is no relation between them. There is no inbuilt security channel.
Okay. Okay. And shall we move on for the vote of thanks?
Yeah, we can. Yeah, thanks.
Okay. So I think everybody for every question they got the answer. Okay. Thank you, Emmanuel, for your wonderful session. Hope so. It will be very beneficial for the participants. And thank you so much. And thank you, Kumar sir, for being with us pet for a long time. Thank you so much. And thank you, Jasmine Mary ma'am, for being the moderator. And thank you, Stanley sir, for associating this alumni webinar. And thank you, Amal sir, and Abel ma'am, and Mahadevi ma'am, for your kind cooperation. Thank you so much. Now, Jasmine ma'am, over to Jasmine ma'am.
I will request Mrs. J. Evelyn Luther, Assistant Professor, Department of Computer Applications, to propose a vote of thanks.
I hope this was a knowledge acquirable session for everyone. First, I thank God Almighty for making this webinar a successful one. I thank our management, CAT group of institutions, Professor Planning and Development, Director Alumni, and Principal for their support. I thank the resource person, Mr. Emmanuel John J. Kumar, for sharing your knowledge and make this session so valuable. I thank our HOD and all other faculty members of our department for their support and materializing this webinar. Finally, I thank all the participants from various colleges and our college for your active participation. Once again, I thank you one and all.
Thank you, ma'am. We thank all the participants for your patient listening. Thank you.
Okay, thanks to all guys.